Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over orbital diagrams and electron configuration. So in a previous video I talked about the different strategies or different principles and rules that you need to follow in order to fill in the table. So I'm going to use those principles and that rule to fill in some examples, and then I'm going to show you how you can write electron configurations and what the electron configuration is. Okay, so let's get into this. So if you remember, there was the Aufbau Principle, and the Aufbau Principle said that electrons want to be in the lowest energy possible. So they're going to start low, and then they're going to work our way up. So when we're putting our electrons into the orbital diagram, they're going to start low. And one of the things I want to say off the off the bat is we want to think of the orbital diagram as kind of a hotel, if you will. And each orbital is a room in the hotel. So we can break this down. So let's say this is our hotel, and our hotel has various rooms. And so there are different floors to the hotel. So think of the energy level as the floor of your hotel. So we have energy level number 1, we have energy level number 2, energy level number 3, and so on. So these would be floors of the hotel. And then we have what they're called the sublevels, the P, the S, the D, and the F. So we have these sublevels that are broken down into orbitals, and each sublevel has a certain amount of orbitals in it, right? So you can think of the sublevel as kind of a suite, right? So there are different suites on the floor of your hotel. There are suites that have one room. There are suites that have 2 rooms or 3 rooms or 4 rooms. So depending on how big the suite is, right? So you can think of different sublevels as being the suites of the floor. And so in the suite you have rooms, and you can think of the orbitals in the suite as the rooms, right? So here we have the D suite, and in the D suite, there are 5 rooms that you can occupy. And so there's a maximum of 2 people per room, right? So let's say, imagine there's 2 beds in each room. So you can house or have two as the maximum of only 2 roommates possible. So if we kind of follow that analogy, then we can think of the electrons as people going into the hotel and choosing their rooms, right? And it's like first come, first serve, and electrons don't want to go into the higher levels because in this hotel there is no elevator, there's only the stairs. So who wants to take the stairs? So when you're putting electrons into the orbital diagram, think of it as people or guests coming to the hotel, and they're going to want to fill in the bottom first, right? So as we're putting electrons into their locations, different rooms of the hotel, this is how the electrons are structured in the atom. So the question is, where are all these electrons? So you have some atoms have 84 electrons. Well, where are they all? Well, this is the answer to the question. This is where they are, right? So some electrons are down in the energy level number 1. Some electrons are in energy levels number 4. Some are in the S sublevel, some are in the P, some are in the D. So where are they? So the answer to this question is the orbital diagram. So the number of electrons of the atom is going to be important. How we fill them in is going to be important to figure out where they are at. And so that's the reason for the Aufbau principle, the Pauli exclusion principle, and Hund's rule. So it's those are to help us figure out where the electrons are. Okay, so with that in mind, let's go over some examples. So I'm going to pick some examples on the periodic table. So let's go ahead and pick um, chlorine. So chlorine is number 17 on the periodic table. So here, chlorine. So number 17, it has 17 electrons because it's number 17. It has 17 protons. That's the atomic number. We're assuming the atom is neutral, and so we are going to put in 17 electrons. And so the Aufbau rule says that electrons want to be the lowest energy possible. So when we're putting electrons into our hotel, if you will, we're going to start with the low energy and work our way up until we've put all of our electrons into the orbital diagram, our hotel, right? So we're going to start here. So this is the sublevel. So this sublevel S, the S sublevel, only has one orbital. So each line represents an orbital or a room. So the first floor of your hotel only has one suite, and that one suite only has one room. So we're going to put two people into that room, and they've got to be spin up, spin down. You could think of this as they have to be male and female in order to occupy a room. That's just the rule. It can't be two males, can't be two females. Got to be male and female. So that's kind of a fitting the analogy there. So we take our 17 electrons and we start filling in our hotel. So we start with the bottom and work our way up. So spin up, spin down. So that level is now full. So this floor is full. It only has one suite, only has one room. So now whoever wants to go in is going to need to go to the next floor. So now we're going to fill in the next floor. So the suite 2S gets filled up. So here we're going to put two of our electrons, spin up, spin down. That suite is full with its one room. Now we go to the next suite, the P suite, the 2P suite on the second floor, right? 2 means second floor, second energy level. So notice there's 3 rooms, 3 orbitals. Remember, that's the PX, PY, PZ. And so we're going to put electrons into there. But remember, Hund's rule says that you need to, if you have equal orbitals of equal energy, you're going to fill in one electron at a time, and they have to have the same spin. So here we're going to fill in 1, 2, 3. So this is like 3 people wanting to have a single room by themselves first. So if this electron goes into this room, this electron is not going to bunk bed or share a room. So they want their own room. So they're going to go to this one, and the third one goes to this one. But then if you have more electrons, then there's no choice. You're going to have to be roommates with someone. Okay? So then here we have 1, 2, 3, 4, 5, 6, 7. We have 10 more electrons, so we got to keep filling. So sorry, we got to put you together. So spin up, spin down, spin up, spin down, spin up, spin down. So now we have 10 electrons. We need 7 more. So we keep going. So the next one is the 3s. So we keep going up in energy, 3s. So we put 2 electrons in there. Spin up, spin down. So there's 2. Now we got to go to the next level, and we got to follow Hund's rule. Remember, the fact that we have to have spin up, spin down in one orbital is the Pauli exclusion principle. So remember, the Pauli exclusion principle says that we can only have a maximum of 2 electrons in an orbital, and they have to be opposite spins. Okay. So here we have 3p, so we're going to have to fill that in with electrons. So again, following Hund's rule, we put them up one at a time. We get our room by ourselves first. Spin up, spin up, spin up. So they're all the same spin. That's 3, right? So right now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 17 electrons, 2 more to put in. So now we have to do spin down and spin down. So that's 17 electrons. So this is the electron structure of chlorine. This is where the electrons are at in the atom. These are the sublevels. These are the orbitals that the electrons are occupying in the atom chlorine. And so this is what the orbital diagram shows us. And so one of the things I want to point out is you'll notice that the chlorine has almost a full third shell here. So we have 3s, and you have this electron here that doesn't have a pair. Now, that's electron wants to be paired because that would complete this kind of level here, the 3s. So that makes chlorine quite reactive. It wants to get an electron so it can complete that outer shell. Okay, so what can I do with this? There's a shorthand way that I can represent and write this out to represent how the electrons are housed in my orbital diagram, in my hotel, if you will. So how can I represent this? Where can I say the electrons are? Well, all I do is I start from the bottom and I work my way up following Aufbau Principle, and I write down the number of the energy level, the letter for the sublevel, and then I write a superscript for the number of electrons at that level. So what do I mean? So let's do this. So notice I have 2 electrons in the 1s. So what do? I write 1s. So that's the first sublevel. I write that. And how many electrons do I have? I have 2. So I put a superscript 2. So 1s2. So that means that I have 2 electrons in this 1s sublevel. Now I go to the 2s. So next I write 2s. How many electrons do I have in the 2s? 2. So I put a superscript 2 for the number of electrons I have at that sublevel. And all I'm doing is I'm going up. As I go up in energy, I'm following the energy and I'm increasing energy. I'm going from low to high. And as I'm going through the floors, through the different levels, I'm writing down the number, the letter, and the number of electrons in that sublevel. So here, 2s. What follows the 2s? The 2p. And how many electrons do I have? That's 6. So I'm going to write 2p, 6. So superscript 6 tells me those are the 6 electrons that go into these 3 orbitals at this level. Okay? Next is going up to the next higher level. That's 3s. So I'm going to write 3s. And then how many electrons do I have? 2. So I'm going to put superscript 2. And then I go to the next one. So the next one is 3p. And so I write 3p. And how many electrons do I have in here? 1, 2, 3, 4, 5. So there it is. So the order of the electrons in my chlorine atom is written out according from lowest energy to highest energy, and all I do is I write it out this way in the same order, writing down the number of electrons that I have in each sublevel, going from lowest energy to highest energy, and that's it. And this, ladies and gentlemen, is referred to as electron configuration. Sorry about that. Lights. So this is the electron configuration. So the electron configuration of chlorine comes directly from how you put the electrons in the orbital diagram. So if the electrons are structured in this way, then you write it this way, and this is the electron configuration of the atom of chlorine. Let's go ahead and do another example. So instead of chlorine, let's do another one. Let's do silver. Silver is number 47. So we got 47 electrons. So here we have, excuse me, here we have 17. So now we have to add 30 more electrons. So we're going to go to 47. So we keep adding. So we put spin down here, that's 18. So we have 3p. So let me put silver here. Oops. We're going to put silver. All right, so I start from the bottom up and I continue. So here I have 18, 3p, and then after the 3p, the next is 4s. So this is 18, spin up, spin down, that's 20. And then I go to 3d is next. I'm not going to 4p because 3d is lower in energy, so we're going to go to this one because, again, electrons want to be in the lowest energy possible. So as our guests to the hotel are coming in, they want the lowest floors possible. They don't want to go up any more stairs than they have to. So this, after the 4s, is the 3d. And so Hund's rule, we're going to do spin up, spin up, spin up, spin up, spin up. And then we keep going. Spin down, spin down, spin down, spin down, spin down. So that's 10. So this was 20, this is 30. So we have 47 electrons, so we got 17 more to go. So this is 30. Next is P4. So next in energy is P4. So Hund's rule again, spin up, spin up, spin up. They want the rooms by themselves, and then we keep adding, and now we pair them up. So that's 6. So now we have 36. So keep going. We got 11 more. So after the 4p, what's next? The next in energy is the 5s. So we're going to add to that, spin up, spin down. So we're going to put electrons into that room. And so now we have 38. So we want 47. So let me double check. So we have 2, 4, 10, 18, 20, 30, 36, 38. And now we want to put in 47. And so the next one over is going to be the 4D. So we got 38. So this is going to be 36, 37, 38, 39, 40, and then 41, 42, 43, 40, hold on a second, I miscounted. 2, 4, 10, 18, 20, 30, 36, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. There we go. I needed one more. All right, so here we have 47. And so this here is where the electrons are in the atom of silver. So now if we write our electron configuration, all we need to do is copy everything from the bottom following the order of increasing energy levels, and we write it in the order. So again, we start at 1s. So the electron configuration is going to be 1s2 because we have 2 electrons here. Next, 2s, 2 electrons. So 2s2. Next, 2p, 6 electrons. So that's going to be 2p6. Next, 3s, 2 electrons. 3s2. Next, 3p, 6 electrons. So that's going to be 3p6. Next, 4s, 2 electrons. 4s2. Okay, we got to keep going. So next is going to be 3d. That's going to be 3d, and we have 10 electrons. So that's going to be 3d10. Next is 4p. They have 6 electrons. So 4p6. Next is 5s with 2 electrons. 5s2. Oops, that's an ugly 2. 5s2. And then next is 4d9. So we're going to put 4d. So we're in 4d, and there's 9 electrons. So we put superscript 9. So this is where the electrons are located in silver. So if you count the subscripts, 2, 4, 10, 12, 18, and you count, you'll get 47. You'll count 47, and this tells you where the electrons are in silver. We have 2 in the 1s sublevel. We have 2 in the 2s. We have 6 in the 3 orbitals in the 2p, and so on. So this tells you what the structure of the electrons are in the atom. So I hope this was helpful. I hope these examples clarified everything. If you like this video, please hit that like button, subscribe to my channel, hit that notification bell if you want to get more videos that I post out on a regular basis. Please put a comment in the comment section. Let me know what you think and ask me questions. Thanks for joining me. Have a great day.